Okay, so initially we discussed about the atom and its structure and the position of electron, proton and neutron. Alright, secondly we have gone with atom combination, we have gone with element, and we have gone with molecular element and molecular compound as well. Today we are going with matter classification, the diagram of matter classification. As you can see here, I have written the topic matter. Now, what is matter? We all know that matter is anything having mass and occupies space. So, let's write the definition here. It is basically anything having mass and occupy space is called matter. Alright, so now matter can be classified on its physical classification as well as chemical classification. So, we have two types of classifications. We have two types of classifications. The first one is physical classification. Let's write here physical classification. Physical classification. And another is chemical classification. So let's write that too. We have chemical classification. Alright, so in the physical classification we have three, it can be further divided into three categories. Wait, let me write the arrows. It can be further classified into three categories. The first one is solid. We are going with common categories, and we would not be going with here plasma, Bose-Einstein condensed state, and fermionic condensed, as we have already discussed about the discovery of those. Alright, here we are going with common states. So, we are going with common states here. The first one is solid. The second we have is liquid, and the third common is gas. Alright, we have solid, we have liquid, and we have gas. Now let's see the characteristics of these. Alright, solid, we know that solid will have a definite shape, definite volume. So let's write this here. Definite shape and as well as definite volume. Definite volume. Alright, while talking about liquid will not have definite shape, however it will have definite volume. Let me change the color. Definite volume but not definite shape. It will have an indefinite shape. Indefinite shape. For example, if you have bought water, alright, in the water bottle. For example, you have a water bottle that is of 1 liter. Wait. That is of basically what? It is of 1 liter. And let's color this. This is of 1 liter. Alright, so you have bought this water bottle and this is of 1 liter. Now you are putting this water into a dish. Alright, this is basically a dish, and you are putting this water in this dish now. In this dish now. Now let's see the statement. What I have written. I have written definite volume but indefinite shape. What I have written, definite volume but indefinite shape. Now let's see. If I'll pour this water inside this dish, I'll pour this water inside this dish. It will take the shape of this container. It will take the shape of this container. This is the container, and this water will take place or will occupy the shape of this container. While if I have 1 liter here, so here I'll have 1 liter too. This does not mean if I'll pour a water bottle, from water bottle to a dish, it would be reduced or it would be gone higher. No, of course not. If it is 1 liter, it would be 1 liter in the dish as well, but it would take the shape of the container. So it has indefinite shape but definite volume. All right. Now let's go with gas. Gas. All right. Gas have neither definite volume nor definite shape. So let's write here. Neither definite volume nor definite shape. So it has neither definite volume nor definite shape. Alright, now let's go with the classification on the basis of chemicals. Alright, this was the physical classification. Let's go towards the chemical classification now. Alright, on the chemical classification basis, it is further divided into 2 categories. Let's divide this into 2 categories. The first one is of pure substances. It is of pure substances. Let's write that. Pure substances. And here we will have mixture. Mixtures. Alright, chemical classification. On its basis, we have again 2 categories: pure substances and mixtures. So what we have in the pure substances, or what are basically pure substances? Let's go with the definition of the pure substances first. Pure substances: if you have a substance and in that substance all the constituent particles are basically the particles from which the substance is made of. Alright, so all the constituent particles are of one type. Let's write here. All constituent particles are of same type. All the constituent particles are of same type. This basically gives you the definition of pure substances. Then again, pure substances is subdivided into 2 categories. Let's divide these into 2 categories. So basically the first one is element, and we have already discussed about that. We won't be going again with it. I have already told you about element, molecular compound. Element. Since element have the same constituent particles, those are atoms, but those atoms are not chemically bonded. Those atoms are physically bonded, as I have already taught you. So here we will have atoms, and those atoms would be of same type. But here we won't have chemical association, we will have physical association. we'll have here physical association. And on the other hand, we have compound. We'll have what? We'll have compound. Let's write that too. Compounds. And how compounds are made basically? With one metallic atom and another non-metallic atom. These are made by one metallic plus non-metallic atom. Atoms. And they'll have what? They'll have chemical association. Not physical, however, chemical association. Chemical association. Alright, they'll have here chemical association. Let's go towards mixture. Mixture is made up of more than one type of constituent particles. So let's write the definition of this too. They are basically made, let's write with white, then I'll highlight it with another color. So made up of more than one type of substances. Type of substances. More than one type of substances. Let's highlight this with another color. Okay, so these are made up of more than one type of substances. We have again here subcategories too. Let's divide this. They are subdivided into two categories. The first is homogeneous mixture. I'll be letting you know about the term homogeneous mixture too. What does mean by this term homogeneous? Let's highlight this. Homogeneous mixture, which is also known as solution. I'll let you know too why it is also known as solution. And here we have heterogeneous mixture, which is commonly known as mixture only. Alright, we have homogeneous mixture and we have heterogeneous mixture too. Now homo means same. This means same. So here the particles will be uniformly distributed. Alright, if I have a glass of water here, and here inside that I have water. Water. Wait, let me size it. Here I'll have water. This is water. Alright, let's highlight it. So this is water we do have, and I am putting NaCl into it. NaCl is what? It is a table salt. So let's put NaCl. Wait, let me resize it. NaCl is what? It is sodium chloride. Na has positive charge and chlorine has negative charge. When we are pouring this into this water, alright, NaCl will be dissolved into the water. It will be dissolved, alright, and that too evenly dissolved. So now it's dissolved. Let's change the color of this. Let's make it now this color, which is showing what? That NaCl is uniformly dissolved into this water. If for example, if I am taking this side now, wait, let's simplify. If I'm taking this side now, all right, I'm taking this side, and I have, for example, I have here 0.5 gram of salt, or NaCl here, and then I need to check that if the salt is evenly distributed or not. Then I am taking a half portion here, and then I'll check how much salt is present here. And if the the value is same as I have taken previously as of first one, it has 0.5 gram of salt too, then we can say salt is uniformly distributed among all particles of water. So this is basically known as homogeneous mixture, in which the particles are uniformly distributed throughout the substance. Distributed throughout the substance. Alright, so here salt is uniformly distributed in entire water. So this is what we call the homogeneous mixture, and this is known as solution too. Just because salt is dissolved into the water, that's why this is known as solution. So let's go with heterogeneous. Now, as homo was same, hetero means different. Hetero means different. Hetero means different. So here, here we'll have different. Like here we'll have mixture. We'll not have solution. The particle which we'll be pouring inside the water here now will not be dissolved into the water. For example, let's take an example of water. Water would be same in all the cases. Alright, here I have water. Let's color this water. This is water. Alright, and now I am putting sand in it. You know that what is sand? Wait, let's resize it. Sand. And we know that when we'll put sand inside it, it won't be dissolved. It would go down and it would settle down. It would not come up, or it would not be distributed among entire substance. However, this would gonna sit down or settle down. So here we have sand particles. They're gonna settle down in the water. So when now I'll do experiment, if I am taking half ocean from here, and I have observed that the sand here present is 55 gram of sand I have found here. And if I am taking the same portion from the upside now, I have found here 0 gram of sand. 0 gram of sand. Since the entire sand is settled down, so we don't have any sand up now, so I have found 0 gram of sand now. So now see the ratio. Here we have found 55 gram of sand. Here I found 0 gram of sand, which means the substance which we have poured inside the water is not uniformly distributed. Here what happened, the substance is not uniformly distributed. So that's why this is the non-uniformly distributed, and homogeneous is the uniformly distributed. So since the sand would not be dissolved inside the water, that's why it is also known as mixture. So homogeneous has the second name, which is solution, just because whenever we put the another substance inside the water, it gets dissolved. That's why it becomes solution. However, when we put something inside the water and it is not dissolved, that is mixture. or heterogeneous mixture. So this was all for today, as we have gone with diagram of matter, how it is classified. In the next video we'll be going with how atom stabilize itself.